Hello all. Analysis of tapered bar using ANSYS Workbench. Consider a tapered bar shown in figure below. Determine the nodal displacement, stress in each element and reaction forces. Young's modulus is given. Area at root is 1000 mm square. Area at the end is 500 mm square. In order to solve this tapered bar, first we have to convert this tapered bar into stepped bar. How to convert this is first what we have to do is we have to take the average of area at root as well as the area at the end. That is 1000 plus 500 divided by 2 will get the average as 750 mm square. So then this 750, whatever we got the average, this 750 is to be added with the area at the root and we should divide it by 2. Similarly, we have to add this average 750 with the area at the end divided by 2. That is the area of the stepped bar. Area of the first element is whatever the area at the root we have is 1000 plus the average is 750. 1000 plus 750 divided by 2 will get 875 mm square. Similarly, area 2 is the area at the end is 500 plus the average value 750 divided by 2 625 mm square. Then we'll get the area at of the first element as 875 mm square and area of the second element as 625 mm square. The total length of the tapered bar is 375. We have divided by 2 for the two elements. So that we'll get it as 187.5 mm and 187.5 mm. Now what I will do here is I will convert this area into radius. How to convert that? We know that area of the circular cross section is area is equal to pi by 4 into d square. I will do it for the two elements separately. Okay. Area 1 is equals to pi by 4 into d1 square. On cross multiplication, we know the value of area, that is 875. Cross multiplication 4 is multiplied divided by 3.14 is equal to d1 square. So we'll get the d1 as 33.38. As we know that radius is equal to diameter divided by 2. The diameter is 33.38 divided by 2 will get 16.69 mm as the radius of the first element. Similarly, we'll do it for the second element too. Now let us analyze this tapered bar in ANSYS Workbench. Open the ANSYS Workbench. ANSYS Workbench, select static structural. In static structure, go to engineering data, right click, edit. Click here to add a new material. Add as material 1. Enter. Now it is an isotropic and elastic material. So now the Young's modulus for this one is 2E5. The Poisson's ratio as 0.3. Give enter. Similarly, I'll take the another material, that is material 2. Enter material 2. After entering the material 2, isotropic elastic material. And the Young's modulus for this one is 2E5. The Poisson's ratio as 0.3. Now this step is completed. Then select the project. In project, go to geometry. Geometry, new design modular geometry. In geometry, what we will do is we will give the cross section and give the length of the elements as well as the part is formed in this step. Okay. Here select the XY plane. Look at units is millimeter. And after that go to sketching line. In line, draw a line. We have to draw a line here from this. No, I'll draw a straight line. I draw a straight line and go to dimensions, general, then give the distance of this one as 187. As we know that the distance of that element is 187.5. So I'll give it as a 187.5 mm. Give enter and then give generate. So that first element is being created. Similarly, next here is sketch 2. Now draw line from the second node, draw a straight line. Draw a straight line. After this, dimensions, general, give the length of this one. It is 187.5 mm. So the two element is created. After this, to give generate. After this, go to the concept, line from sketches, select the first line, give apply, then generate. So that one part is created here. Similarly, concept, line from sketches, select second element, add material. We have to add frozen and give apply, give generate. So the two parts and two bodies is created here. Now we should give a cross section, concept, cross section, circular for the radius we should give here. As we have already calculated, the radius of first element is 16.69 mm. So I'll type it as 16.69 mm. Give enter and give generate. Next, I will take the another cross section, circular, and again the radius of the second cross section is, as we know that it is 14.10. So I click here as 14.10 and give enter and generate. So you can see that two cross sections is being created here. And here in a line body, select first line body and give the cross section as circular 1, give generate. And again line body 2, select the circular 2, give generate, and select line body, and again keep hold the control line body, select both, right click, form a new part, and then close, give generate and close this step. And this step is completed. Now we have done the material properties. Then we have completed the modeling, geometry. Now we should go for the modeling. In the modeling step, we will apply the loading conditions, meshing, everything done in this step. Okay. Now here I click edit. Edit. Here we have different options. Okay, we can see here we have a selection, automation, add-ons, learning and support, restart, analysis, rotor dynamics, etc. And also we have eye cross section here. We can display everything is possible here. Okay, and here in this step, select a geometry part, line body. We have to give the assignment here. Which material is this one? Material 1. And similar line body, second line body we have to select. For the assignment, you should give it as material 2. It is arbitrarily taken as structural steel, but you should change it to material 1 and material 2. Now go to the meshing. We have a mesh here. In the mesh, right click, give update. So that you should give the update the mesh. You can see that we have a different here. This is one material and this is one material. After this, we have to after this we have to do the eye cross section. Select the eye section. Okay. After considering the eye section, go to the static structural environment, and the first node is fixed, so that we can see that the first node is fixed. So we have to consider fixed node, and we should select the vertex. Select the first node and give apply, so that the first node is been fixed. Similarly, we should fix the node number 3, that is we are applying the force here. So select the force. After this, select the component. X component is 100 Newton, and select this one and give apply, so that we can see that the first node is fixed and the third node we are applying a force of 100 Newton. After this, we have applied both the boundary conditions here. Go to the static structural, right click, solve. After this step, we should go to the solution. Solution, insert beam tool, and insert a beam tool here. In a beam tool, we have direct stress, minimum stress, as well as the maximum stress. Before doing this, clicking this, we have to evaluate the results. Right click solution, evaluate all results. Now we can see the direct stress. The maximum stress is 1.602 into 10 to the power of 5 Pascal, and minimum is 1.1436 into 10 to the power of 5 Pascal. Okay, so we can have a minimum stress, maximum stress, etc. If you want to know the deformation, again right click. Now here insert beam tool. Otherwise, we can select deformation, total deformation. If you want the total deformation, click on this one. Before clicking this, you have to again evaluate the results. Now we can see the total deformation is 0.2574 meter as the maximum deformation. Minimum deformation is 0. Similarly, if you want to see the reaction forces, again click on beam tool. Here you have to insert beam tool. You have to insert. Go to beam tool, insert. We have probe here. In a probe, select the force reaction. Okay, as we are applying it in the fixed end. Okay, fixed end, we are applying the reaction force. Select this one, and here we give a fixed support and give enter, so that the force reaction also we can determine. Okay, after this, again evaluate all results, so that we can also get the reaction forces. If you want to see the direct stress, this is the direct stress value, minimum stress, maximum stress, this is a reaction force, and this is a total deformation. If you have to see this all at a time, you can click on solution, and we can get a worksheet's result summary here. You can see that direct stress, the minimum is 1.14 into 10 to the power of 5, maximum in Pascal, minimum combined stress, maximum combined stress, total deformation, minimum deformation is 0, maximum is 0.257 meter. Okay. Force reaction is as we are applying in the fixed end, so that one side we have 100 Newton and the other side it will be a reaction support of minus 100. This is the entire problem we can solve in the ANSYS workbench. This is the summary of the results. We will get the maximum stress, minimum stress, as well as the total deformation. Thank you.